Indra, innovative solution for heating system. Indra is able to manage automatically the air conditioning system of your house or office. It controls each single room thanks to a distributed network of sensors that periodically take temperature and user presence. So it sets the correct power of the conditioners in order to ensure the best level of comfort and energy saving, basing on a dynamic threshold and according to the actual and historical user presence.
The system shows some innovative features. In order to optimize the air conditioning, it is able to predict the user presence based on statistical developed on periodical detection of people. In fact, it tunes the air conditioners in response to a temperature variation only according to the current and the near future user presence. To minimize the consumption, the system turns on the air conditioning gradually through management of power and timing. Moreover, the system allows to manage the number of controlled rooms automatically, adding or removing some of them. It also interacts with the user who can express his preferences and see in simple graphical way the state of the house or office. And the structure and the technology of the system permit to integrate new applications too, for example, like control sys. The system is based on distributed architecture software that provides a powerful scalability. The communication between elements of the system is mainly based on Internet protocols like MQTT and COP, but in few applications a RESTful HTTP approach is used.
The elements of the system are the following. Concentrator coordinator node for each room, to which three types of sensor physically linked: temperature, humidity, user presence. Broker for MQTT communication. Central management unit to data processing and switching on-off control. Weather web service to provide and calculate the optimal temperature threshold. Statistic web service for the data storage of users' routine. Web client for the data visualization. Web client for user preferences. Each element has a unique ID and IP for QM communication and an ambiguous identification. First of all, using a reliable and external provider, the broker and the central unit communicate their IP address in the LAN in order to connect all the elements of the net that start to communicate their existence. In order to ensure that the system works correctly, each element publishes periodically its main information via MQTT to the broker, to which is subscribed by the central unit. These informations are used to update a file called resource list. These data are exposed and used by other elements that can know dynamically which devices are in the network and interact with them. This feature is fundamental for future expansion of the system. In every room there is a concentrator coordinator node, which publishes in MQTT on the broker every 15 minutes for the relay state, humidity and user presence. The temperature instead is published only when it changes in a room. Each data is exposed to a specific MQTT topic that allows a simple and unique access to the userful information. These data are saved by the central unit for data management.
In order to guarantee a dynamically updated of the optimal temperature threshold, the system includes a weather service that publishes it on a specific topic. To calculate the correct value, the tool communicates 4 times a day through an HTTP REST protocol with Weather Underground website that provides for the external temperature. Thanks to this value, the threshold is modified based on the time of the day and the seasons for allowing energy saving. This data is used by central unit for the decisional process. Besides, the user can modify the threshold for the desired slots of time thanks to COP web client that immediately communicate the preferences to central unit.
Taking Getting the data from specific topic, the system allows a simple graphical visualization from every device, as smartphone, tablet and PC, just connecting to Freeboard.io and ThinkSpeak. The first one shows the current state of relay and temperature in each room. The other one displays the temperature trend for a selected number of days.
Every room node periodically controls the user's presence. These information are published to the broker, and the central unit receives this data with subscription and organizes a file with weekly users' behavior. Once a week, these info are delivered only for current active rooms to the statistic web service that organizes and predicts the future user's presence for every hour in the week. When there is a specific request, the server provides the probability of user presence via co-op protocol. Each hour it publishes to the broker, for the next 2 time slots, the probability to have the user's presence only for current active rooms.
When the temperature arrives to the central unit, first of all it searches for user setting in the current range of time. Otherwise, it sets the threshold with the value received from the service weather. If this service is not active, an emergency system sets it to a default value. If the temperature is in the settled range, the system asks for relay state, and if the relay is on, it is switched off. If the temperature is out of range, the system asks for user presence, and if there is someone, it calculates the best value of power that ensures the correct heating of the room, and it sends it in co-op to the node that tunes the air conditioner and switches the relay on. If no one is in the room, the system asks to the statistics server in co-op for the probability of presence in the current hour. If probability is greater than 85%, the optimal value of power is calculated and sent in co-op to the node, and the relay is switched on. If probability is less than 85%, the system accesses to the local statistic JSON file to know the probability for the next 2 hours. Only if the probability in the first hour is greater than 60% and the probability in the second one is greater than 60%, the power is calculated and sent in co-op to the node, and the relay is switched on. But the threshold temperature is set to the 90% of the default value.